Good morning, everyone. I would like to thank Kent for giving us this opportunity to present on some of the recent happenings in the area of automation. I am joined by Nitin and Rajvi from my team in today's presentation. Okay, a brief introduction about us. We are part of the manageability engineering team, and we work on the automation support for Junos devices that covers both on-box and off-box automation. And today we will be talking about Junos Snapshot Administrator that is developed in Python, its architecture, features, and followed by a demo. Here you can see the big picture of Junos automation feature stack that is, of course, carefully and consistently built over many years, starting from the standards-based netconf XML RPC infrastructure all the way up to the support available in terms of Chef, Puppet, Ansible, and now Salt. This is the one which is being frequently used across several network automation scenarios across our customers. Now, moving to the topic of the day, which is JSNAPy, which is Junos Snapshot Administrator in Python. This is an earlier version of JSNAP that was developed in Slacks, a Juniper proprietary XML-based language that is now rewritten in Python and with additional features. This can be used in test automation and network auditing. This will require you to have a simple knowledge of YAML to get started and can help you in taking device snapshots and then writing test cases on top of them. It can be used as a command line tool or be integrated into a larger framework. It's a single solution that will work with the devices from Junos 11.4 to the latest. A quick look at the architecture. It is built on top of the same standards-driven netconf support of Junos that is implemented smoothly using PyEasy, one of our very commonly seen micro framework that lets you do netconf with Junos devices over a secure shell. JSNAPy in Python can be used to take snapshots of the device status. These snapshots can be used directly or in comparison. They can be used with or without test cases. The snapshots can be compared across timelines to monitor changes in configuration or operational state. Here, let's take a look at some of the key features that will let you take snapshots, compare snapshots, validate data, or conduct audit of the device based on user-defined test cases. These test cases can be defined in YAML-based test files. Some of the additional features that are available include the ability to import as a Python module. This is primarily targeted towards power users who can integrate it into larger frameworks, say like Robo framework or Ansible, etc. You can connect to multiple devices. You can filter the snapshots by passing arguments. You can even have a mail notified of the test result. You can store snapshots in a database and then retrieve them later for analysis offline. The test cases can be written in two modes. Essentially, the tool itself can be used in two modes. In the case of direct, you extract the device status and then run test cases on top of the device snapshot. In the case of comparison, you take snapshots across timelines and then compare them for any changes. So the operators that are available for you to write test cases in the case of direct mode could be an equal to operator, a not equal, a less than, greater than, in a range, not in a range, contains, etc. In the case of a comparison, the test cases can be built using the operators like is the list of data that you get same, are all the options same. You can use a regular expression to compare the values that come in, etc. Let us look at how to use the tool. A simple YAML file defining the host and its credentials, followed by the tests that you would want to run, can get you started. So here you can see that I am defining a device named router with its credentials and two test cases to be executed. The tests themselves are defined in YAML. So here you can see that I have a test case to be executed wherein I run the show interfaces strs command on the loopback address. I provide the XPath keyword for the content to be parsed and then use the is equal operator on the admin status and I expect it to be up. Simple test case, isn't it? Let's look at another test case. The test BGP test case is utilizing the RPC get BGP neighbor information. Here I have two test cases defined. One is a not equal in the sense the last status I don't want it to be idle. I don't expect it to be idle. Similarly, I expect all the flap count to be same. So I have two test cases utilizing single RPC data. So this is how the test cases are defined. Let's look at a quick run on how the tool can be used. As a command line tool, I can use the JSNAPy to get a snapshot of the current state. You can see the log which says I am running it to capture a snapshot for show interface strs on loopback and a run of the RPC get BGP neighbor information. Here you can see the content of the snapshot, which is essentially the XML RPC replies of the commands and the RPCs that you have specified. Let us see how to execute a snapshot followed by a check. So in this case, I use a snap check operator. I take the snapshot and I run certain test cases. So here in this case, I see that the admin status is equal to up, so the test case has passed. Whereas the BGP has failed because the last state is equal to idle, whereas I expected it to be not idle. And the flap count test case has passed. The snapshot snippet can be seen here, wherein the required values are present. Moving on. Here is a case where I want to compare two snapshots that are taken. So there is a pre and a post, and I'm comparing them with a test case. Here, the pre-snapshot, the admin status was up. In the post-snapshot, the admin status is down. So the test case has failed. You can see here I am comparing two snapshots, pre and a post, using the diff option, which lets me compare two snapshots without any test cases. So the tool provides you all the differences. So here you can see that admin status was up, has become down. So you can get a visual representation of the differences, which are color coded. Now for the power users who want to have a Python-based scripting, can utilize the module SnapAdmin, which provides the functionality in a programmatic way. You can configure the same config files, snapshots, checks, and iterate through the results of the test case execution and then take appropriate action. Here we are printing the results. You can potentially take further actions based on the test results that are available. So in summary, the tool brings you the flexibility of simple YAML-based configuration and test files to audit a device at one end, and at the other end gives you a powerful Python module to programmatically handle network audits. This would greatly help in moving and automating the mop and auditing functionalities away from rancid or such equivalent screen scraping. We do have an Ansible integration that is working in progress, which should enable you to even integrate this tool into the Ansible framework and let you do auditing across the network. I am sure this will be of use to a lot of network engineers out there. the current status